All right, so next thing we want to do is we want to talk about organizing a statistical problem. So we're going to introduce you to a four-step process that the book uses very well and thoroughly throughout the entire book. So very important for you to understand this process. It will be part of a lot of the work that you do, and especially for the free response questions that you'll be asked as part of the AP exam. So you want to be able to structure your answers in a way that makes sense, and so the book is going to help you with that process. All right, so the process is going to be you want to state, plan, do, and conclude. So you want to state the question you're trying to answer. You want to plan how you're going to answer the question and identify the statistical techniques used. And don't worry, you'll have plenty of examples for all of this. I'm just going to give you an overview, and we'll have an example to do during class time. Do make graphs and carry out needed calculations, and then conclude. You're going to draw conclusions and inferences. Remember, we talked about that in the last video from the data that you're provided. So let's go through an example. So a survey was given to men and women aged 19 through 25, and they were asked, what are the chances you will earn more than the middle class income by age 30? And so the total was given by gender, female and male, as a frequency. So almost no chance, some chance, but probably not, 50-50 chance, good chance, almost certain, and then the total count for each. And so we want to use this information to organize a statistical problem. So let's go through how we might answer a question. Maybe you could think of questions that you might have given this information. All right, so let's state, we're going to state the question we're trying to answer. So looking at that data, I want to understand the relationship between gender and responses. I've been given male and female on the responses, so I'm interested to know if there's any difference between the two genders and how they responded. So plan, I'm going to figure out how gender is going to influence opinion. So I'm going to compare conditional distributions between the two. And that's the planning part. So I'm going to plan how I'm going to answer the question and identify the statistical technique used. So we're going to use distributions here to compare. Then I'm going to do the work. So I made and carry out the needed calculations for the conditional distributions. And you can take a look at this. And let's see if just looking at this, if you can come up with any conclusions that might be interesting. And then we're going to make a conclusion, or actually we have a bar graph comparing the two, and that might help us to synthesize the data that we just took a look at. So here's a bar graph with a legend. And then finally we're going to conclude, based on the observations of the data, men appear to be slightly more optimistic about their chances to earn more than the middle class income by the age of 30. Less than 50-50 chance, men are 15.6, women are much higher. And better than 50-50 chance, men are 55.1%, and women are 48.5. So this conclusion is going to necessitate that you take the data and you analyze the data to provide some quantitative analysis of the results and then make your conclusion off of the quantitative analysis. All right, so that brings us to the last thing that we want to talk about, and that is Simpson's paradox. Okay, so I'm going to give you an example and explain Simpson's paradox. So Simpson's paradox is an association between two variables that holds for each individual value an association between two variables that holds for each individual value of a third variable that can be changed or reversed when the data for all of the third variables are combined. All right, so what does that mean? All right, so let's give you an example. All right, so this is a study of how accident victims are transported to the hospital and whether or not the victim of the accident died based on how they were transported. So you can see helicopter, 64 people out of 200 died. So we're going to use that conditional distribution. And road, 260 out of 1,100, which means that 32% of helicopter patients died, while 24% of road patients died. Now, this would seem counterintuitive because the helicopter is going to be much faster than people who are taken by ambulance. So we want to think more clearly or closely about this, and we're going to relate this to Simpson's paradox. So now what we're going to do is we're going to break the study out into serious accidents and less serious accidents. And this is so your third variable. And we're going to break it out now between these two. And we can see that helicopter and serious accidents, helicopter patients, 48 out of 100 died, whereas in those brought by an ambulance, 60 out of 100 died. And now for less serious accidents, 16 out of 100 died. For less serious accidents, and for road, 200 out of 1,000 people died. So here is the paradox. The paradox is, in the prior slide, in the prior analysis, we said the relative number of victims who died was greater based on what type of transportation, and that was for helicopters, 32% of helicopter patients died. And that was greater than the 24% of road patients died. But when we split up the data using another variable, we take a look at the data, we see that for serious accidents and less serious accidents, both individually, the likelihood of dying by being taken by helicopter actually decreases and is now less than road for both of these categories. So in total, if we take the total of these two, then helicopters are, let's say, more risky, have a higher percentage of people dying. But when we consider them individually, helicopter patients have less likelihood to die. And so this is what's called Simpson's paradox. So we can see that overall helicopter transport is less effective, but individually it is more. So if I take a look at the total deaths, 32% of those people transported died for the helicopter patients, whereas 24% died for the road patients. But when we break that out by serious and less serious accidents, it's actually less, 48 versus 60 and 16 versus 20. All right, so that brings us to the end of our discussion on analyzing categorical data. When you come back to class, we'll have a problem for you to do on stating, planning, doing, and concluding. And then we're going to move on to chapter 1.2. And in 1.2, we're going to talk about displaying quantitative data with graphs. So please join us next time.